Hello everyone, welcome to Pepcoding. So today in this video we are going to discuss another question based on tree, that is burning tree. So according to its name, you can identify or you can just have a vague idea that what this question is actually going to be. So let's say we have a tree, binary tree, something like this: A, B, C, D, E, F, G, H, I, J, K, L, and M. So let's say this is our binary tree. I'll just make it more visible. So let's say this is our binary tree. Now what is this actually? This question is actually asking to us. This question is saying that if I start a fire at this node, let's say at ith node, then at which time or what will be the maximum time that the fire will take to burn the whole tree? Okay, so the question is that if I start burning this node and it takes 1 unit of time to reach, that is 1 unit of time to reach here, 1 unit of time to reach here, and 1 unit of time to reach here, and so on. As I go up or as I go down, it will take time that is going to be one unit more than the previous unit or the previous time. Okay, so what I'm actually trying to say here, we can see that if here I start the fire from this node, then to burn or to reach the fire takes time to reach here of 1 unit. That is, the time taken by the fire to reach to the J node is 1 unit. The time taken by the fire to reach till K is 1 unit. Now from here K to L, time taken by the fire to reach is 1 unit, but with respect to I, time taken to reach taken by the fire to reach L is 2 unit. So we have to keep I as the starting node, and from there we have to calculate that what is the maximum time to burn the whole tree, which means that I'll show you that from here it will take time of 2 seconds or 2 units. Here also it will take 2 units. From I to reach E, it will take 1 unit, and from E to reach H, it will take 1 unit, but from I to reach H, it will take 2 units, because first fire will travel here, then fire will travel here. Right? Now, if this much is clear to you all, now let's move further. From E to reach here, that is from I to E and then E to C, it takes 2 units. Then it again takes 3 units to reach here. From C to here, it will take how many units? How much units? It will take 3 units. And now from A to B, it will take 4 units. From B to F, it will take 5 units, and from B to G, it will take 5 units. Right? This means that if there is a node and it has 2 branches, then the fire will simultaneously, that is, fire will take the equal amount of time to reach both of its child. This means that the tree is actually burning in which manner? The tree is actually burning in this manner, in BFS manner, that is level wise. The tree is actually burning in level wise order. That means first this will burn, then these two will burn. That is, the fire will spread simultaneously to these branches, and from here the fire will spread simultaneously to these 2 branches, and from here to here. We can see that it is a problem of BFS, that is, the fire is going to spread level wise, but we are what actually doing here? We are actually traversing in DFS, that is, we are doing depth first, search first. This problem can be solved using or can be solved using BFS also, but here for this problem we are going to use recursive approach. So recursive approach is nothing but RDFS. So with this, I hope that the question was clear to you all. That I'll keep it as it is here. The question is that if I start fire from here, that is ith node or any node in the given tree, then what is the maximum amount of time it is going to take to light the fire or to burn the whole tree? So here we can say that max time that it is taking is total 5 seconds or 5 units of time, right? 5 unit of time. So now let's discuss the approach, that what we are going to do in this question. Let's see. If this is our binary tree, and we start our fire at this position, that is at the ith node, then how much time it is going to take to burn its lower half? Let's see first that. Okay, so for that we need a stack. We are going to discuss a recursive approach, therefore we are going to use what? We are going to use a stack. Okay, now in this stack, first make some lines. Okay, now here you can see that from I, first we make a call to its left child, that is the fire is going to first spread here, that is to left, towards the left. It took 1 unit of time, so here we will maintain a count of time, that is 1 unit of time, right? Similarly, from here it returned back here, or sorry, I'll say when it make a call to left child, it is going to be here j, and that first here it was 0 second because I started fire from here only, so it took 0 seconds to burn this. Now for the time taken by the fire to spread till j is going to be 1 unit of time, right? 1 unit of time. Now j will call to its left, that is the fire will try to spread further, but it will see that this is the end of the tree, so this will not go anywhere, that is from right, this will not go anywhere. Now currently my max time, I can say max time is nothing but, first it was 0, but now it is updated with this one, right? We are going to update this max time at each level whenever we are going to get a maximum value. So both the calls for left and right are done for j, so j will wipe out of the stack. That means that we have returned to ith position. Now I will make a call to right, that is the fire is going to spread from this branch. Now to go here, it took how much time? To reach k, it took 1 unit of time. Now from k to reach l, k will call whom? To its left child, that is going to be l. So from k to reach l, it took 2 unit of time. As it took 2 unit of time, my max time will update. So my max time will be 2. That means to reach l, it took 2 unit of time. Now left will make a call to its right child, left child and right child, but there was nothing here. This means that this is the end of the tree. With this, both the calls for l is done. It is going to wipe out, and before wiping out, it will going to return what? It will going to return to k. So now currently we are having time as 1, that is the fire that is going to spread from here is going to start with k, 1 unit of time, which means that if a fire starts to spread below the tree from k position, then it is going to take some time, that time is going to start from 1 unit of seconds, or can say 1 unit of time, but my max time is going to remain 2 as it is, right? Now from here it is going to go here, that is to m, to till m, that is the right call, and at m it take 2 seconds. This 2 and this 2, this 2 is not going to replace this 2, because we can say that max of 2 comma 2 is nothing but 2 only, therefore this is going to remain same as it is. Now m is going to make a call to left and right, both the calls are done. It is going to return, because this was the end of the tree, this was end of the tree. Now this is going to return here, right, to k. Both the calls for k are done. It is going to return here, it is going to return I to I. Now both the calls for I is also done. It is going to wipe out of the stack. Okay, so this max time 2 tells me that to burn this lower half of the tree, it took me 2 unit of time. We can say it as it to burn the lower half of the tree, that is from I till m and l, it take me 2 unit of time, that is 2 seconds. Let's consider the time unit as in seconds, so it took me 2 seconds. Max time is updated to 2 seconds. Now I have to find that what will be the time it will take to burn this tree, that is the upper half tree. Okay, so now to find this, what we are going to do, let's say this was for lower half tree, right? This stack was for lower half tree. Let's make another stack. I'll minimize this stack. I'll just minimize this stack. This was for lower half. Consider this stack as for lower half. We'll create another stack in red color. This is going to be for upper half tree. Okay. This is going to be a stack for upper half tree. Now what is actually going to be happening here? Let's say if we have seen the previous video, that is the previous question, that was find node to root path. In that in that question we have used the concept of blocker node. So what we used to do, if we want to find here also we are going to use the same concept. I'll just give you a recall and give a reference using this question only. Let's say I am currently standing at this position. That means the fire is at this position. From where the fire came from I to this position, which means that this branch is already burned. Now the fire will spread to this branch, that is it will go to H. Now again will that fire will is it possible that again the fire will go to I? No, it is not possible, because that part of the tree is already burned. Therefore there is no meaning in burning that part again and again. So therefore for E we have to send this I as in blocker node. This means if a parent or if a node receives fire from below fire from its child, then it should not travel to that child again, because that child has already burned. Therefore there is no meaning to burn that child again and again. So with this we are going to use blocker node concept here. So let's say from here I'll just go back. Okay, now we are at 0. So from now, so we are at I, that is with 0 unit of time, that is 0 second of time. Now the fire reaches here to E. To E the fire reaches. This means that this connection has already burned down. So to reach E, 1 unit of time was used, right? Now from here the fire will travel to the left of E, that is to H. So it made a left call, that is it made a left call, and it got to H. And from H it took how many units of time? It took 2 seconds. So at H it took 2 seconds. Now H made call to left and right. There was nothing, so it is going to return here. This means that H is going to be wiped out of the stack, right? Now at this point, when E tries to make a call, or the fire tries to spread to the right part, it sees that it has already burned. This means that this part has already been burned down. This is going to be burned down, and to burn this downwards part, that means to burn this lower half of the tree, it took 2 unit of time, that is 2 seconds. So we have already updated it with 2 seconds. So for now let's consider that here what was here? It was I. It was I here, and I is being sent it as blocker node, which means that I is already burned down. So we are not going to go to I again. Okay, so I hope that this was clear. I hope that I was able to make myself clear that why we are not going to travel to I again. Now from here E will go to this position, that means from 0, and it took time of 1 second. You can see that 1 second. Now both the calls for E are done. Therefore this is going to be going to go to C. Right now we are doing the reverse calls. Okay, actually in the stack this is going to look as we are going to come to C from A, that is from A we are going to jump to C, then to E, then to I. But right now we are going in the backwards direction, just to show you that how the fire is going to spread to its parent, and how the fire is not going to travel back to the same position, that is to the same part of the tree where it has already burned. Okay, so with this it came to E and it took 2 unit of time. So here we can see that for C it took 2 unit of time. C has a left child, it called to its left child. To reach here it took 3 unit of time. So to reach D it took 3 seconds. Now D will tell left and right is null null, therefore both the calls for D are done. It will wipe out of the stack, right? Now currently we can see that here we saw that there was 3 return, right? For D it took 3 unit of time, therefore our max time will also increment, or max time will be also changed, that is it will become 3, right? We have to keep a track of max time also, because we have to, in the end we have what we have to return, we have to return uh, what will be the maximum time to burn both the to burn the whole tree, right? Now this is done. Now for C, left call is done. For the right side, for right call, we are sending this E as a blocker node for with respect to C, because from E only this fire has spreaded. So there is no this means that this E has already been burned. E and its children has already, so therefore the fire will not travel to E again, right? Now both the calls for C have done, and similarly it will go to A. With to A it is going to go with 3. So with 3 we are at, currently we are at A. For A this C is going to be blocker node, and this connection is already be burned, this branch is already burned, which means that this tree is already burned, right? With this we can see that how this tree is burning. This tree is already burned, lower half of the tree is already burned. Max time took till now max time took is 3. Here you can see that to reach A it took 3, and 3 is already here, so we are not going to update, or we are not, even though we update it is going to remain 3 only. Now from A we go to B, that is from A we go to left child. Right child is already blocker node, therefore we are not going to go there. So for B it took how many time, how many units of time? It took 4 units of time, so this is going to update to 4, right? Now from B it is going to go to F, it will be 5, updated to 5, that is from A it is going to be B. Left it is going to be with 4 seconds, and F it is going to make call to left and right, it is going to be nothing, but here time was 5, therefore we updated the time. Now this is going to wipe out of the stack, we are going to fall back to B. Now from B it is going to make a call to right child. To right child, when it makes a call it is going to go to G. Left and right it is going to have the 5 unit of time. This means that the fire reached to G with 5 units of time. We have already updated, therefore both the calls for G are done, that is null null, it is going to be null and null, therefore G work for G is also done. This means that this part is also this is going to fall from here to here, and both the calls are done from here to here. This means that total unit of time taken to burn the whole tree is, that is this part is already burned, because we fall back to A, this part is already burned and A is already burned, therefore we can say that total unit of time taken to burn this whole, sorry, total unit of time taken to burn the whole tree is 5 unit of time, that is 5 seconds. Now we can see that now let's see that this tag, if this tag was confusing to you all, let's try to understand that how actually this stack is going to work, how we are going to use concept of blocker node and node to root path. Actually what we are going to do, if let's consider this is our tree, let's consider this was our tree, what we are going to do actually, I'll make a stack here. Actually, we are going to travel from A to its left side. First, we are going to see that at which node we have to start fire. Let's say we have to start fire at I. Okay, let's say we have to start fire at I. Then we are going to search for the ith node, that is from the root node we are going to search for the ith node. This is nothing but find node to root path. Okay, so for this we are going to fall to C, that is C. Then we are going to go to E. Then we are going to go to I. The moment we get I, what we are going to do, we are going to call a new function. That function will start burning tree, and it is going to return us the maximum time. That is, it is going to return us the maximum time required to burn the whole tree. Okay, so for E, so for I, it is going to give us the maximum time to burn this tree. But from here, the max time, that is going to be a global variable, or we can say that a static variable. It is going to keep on updating here. But from I, what we are going to be, let's see, from A to B, that is from A to C. So from A to C it is going to go, then it is going to go to E, then it is going to I. From I, as we encounter the I, we make a new stack, that is we make a new function that is going to return us what? That is going to return us nothing but that is going to return us the total time taken to burn the whole tree. That is to burn the whole tree, this tree, sorry, to burn this tree with respect to I. That is going to return us that. And similarly, then after this we are going to pass this I as a blocker node for E, and we are going to find that what will be the time taken to burn this whole tree with respect to E. After this we are going to do nothing, but we are going to again send E as a blocker node for C, and we are going to see that what is the total time taken by this C, the total time taken to burn this whole tree with respect to C. After that we are going to do nothing but we are going to keep C as a blocker node, and we are going to see that for A, from A to burn this whole tree, how much unit of time is taken. And as this whole tree is burned, we are going to the A is also going to be burned down. So therefore this is how the stack is going to be. There will be two function stacks, that means there will be two recursive calls, right? That one is going to find that where this node is present, that is the starting node is present, and from there how from the starting node how the fire is going to spread out and what will be the maximum time. So let's code this question. After that we will do a small dry run. Now let's code this question. Here first we are going to do what? We are going to make an global variable that is going to be max time, or let's say total time, right? And initially it is going to be 0. Now in this function, in burning tree function, when this burning tree function is called, what we have to do, we have to make another function that is going to give us the final value, that is going to first travel to that root node, from travel to that node where the burning from where the fire has to be started, and with that we are going to see that how the tree is going to burn. So let's do it step by step. So first what we do, we call to burning tree and we give it name as burning tree slash, and what we are going to pass, we are going to pass a root node and our fire node, and initially we are going to use total time. And what we are going to return from here, we are going to return total time, right? Now we are going to create a function called as burning tree. Let's name it as burning tree 1. Okay, so it is going to be of int type, that is going to return us some value. And now it is going to catch two things. First thing is going to be tree node, that is our root node, that is going to be our starting node from where we have to start searching for our fire node. And second is fire node. That is going to be an integer value. Fire node. Alright. Now this part of code is going to be same as the previous question, that was find node to root path. So what we used to do in that question, first we used to make a call to left, that is going to be left time. We'll call it as left time. Okay, and this is going to call to which function? This function only. And here we are going to pass root as left part of the tree, and we are going to pass our fire node. Okay, and similarly we are going to make a call to whom? We are going to make a call to right time. And here right node will be passed, that is right subtree will be passed. Okay, now what was our base case? Our base case is going to be if our root is equal to null, then do what? That is null pointer, then return -1. This means that we didn't found the fire node in the whole tree. Okay, this -1 means that we are not able to we were not able to find any fire node in the whole tree. Now second condition, what can be second base condition be? The second base condition can be that if our root is equal to fire node, that is if the value of the root node is equal to the value of fire node, then we have to do something. But before doing something or after doing that, we have to return 1. This return 1 means that we have found the root node, that we have found the fire node. Okay, now what we have to do, we are from here we are going to call burn tree function, and this function is going to actually give us the maximum amount of time or maximum time that it takes to burn the whole tree from that particular point to the end of the point. That is, it is actually going to tell that if we found I, we are going to pass I as the main node, and from here the fire has started, and we are going to pass what will be the for I, what is going to be the null or blocker node. For I there is going to be no blocker node, because from I if we start fire, the fire is going to be spreading in the downwards direction. Therefore there is no node or there is no branch in this particular tree that will be on fire or that will be set on fire or that has been burned down before I. So because I is going to be first node, so from here there will be no blocker node. So what we are going to pass? We are going to pass root. We are going to pass total time, that is initially going to be 0 seconds, and we are going to pass null node. Okay, now if we get in value that is non-negative value, that is, this means if left time is not equal to -1, then this means that the fire node or this fire node or the fire has started from the left subtree. Okay, the fire has started in the left subtree. So we are going to do what? We are going to again call this function, that is burn tree. Okay, yes, we are going to call this burn tree with root node as what? The current node as the starting node, and the time that we calculated here, that is going to be here first. Oh yes, we are going to send time, and then what will be the blocker node for this? The blocker node is going to be root of left, that is for left. If I found a root node, or if I found a node where fire was started here, so for this E we have discussed that the blocker node is going to be I. That is, if at the left side or if at the right side I have found the fire node, then the right side of this parent node is going to be a blocker node. So that is what we are going to send. And now we are going to say return our time, that is left time plus 1, right? Now similarly we are going to do the same steps here also. Just instead of left time, what we have to write, we have to change it with right time. Instead of left time, we have to change it with right time, and here the blocker node is going to be right node. Okay, now when this all these steps are performed, that means that all the steps are performed, and if we are unable to find the fire node, then do what? From here we have to return -1, right? Now let's write this function, that is burn tree function. Burn tree. Now what are the values that it is going to receive? It is going to receive a root node, it is going to receive time, and it is going to receive another node, that is going to be blocker node. So we will name it as block, right? Now what this function is going to do, this function is going to do, first it is going to go in the left side, it is going in the right side. Okay, first we have to make 2 calls. Those calls are going to be at the left side of the tree and right side of the tree. So for this, what we are going to pass, we are going to pass root left with what? With time as increased time. Why we are increasing time? Why we are giving time +1? Because from here to reach somewhere, or let's say from here also, from here to reach here, we are going to use 1 unit of time. From here to reach here, we are going to use 1 unit of time, but previously we have used 1 unit of time. So both 1 and 1 are going to be equal to 2. So this means with respect to I, the time taken by the fire to reach till M is going to be 2, and the blocker node is going to be same. Now similarly for right, and in this function we are going to do what? We are going to update our max time, that is total time is equals to max of the current time, or let's say total time in the time, right? And now what is going to be the base condition? The base condition is going to be if we reach to the root reaches to null, that is the tree is fully burned, or we are at some position where we found the blocker node, then what we have to do? We have to just simply return from here. Okay, so our function is almost complete, the program is almost complete. Let's try to run this code and see if we are getting the correct output or not. It is giving us the correct output. Let's try to submit this code, and all the test cases are passing. So with this, I hope the code was also clear to you all. Let's do a small run, small dry run on this code. I'll copy this, or I'll just take this code to our open board. So give me 1 second. Now here let's consider this 50 as a fire node. Okay, let's consider this 50 as a fire node. So what we are going to do, initially we are going to come from this particular point, that is we are at 10. Now this 10 is going to make call to whom? 10 is going to make call to left child, right? Sorry, it is going to make a call to left child. Again it is going to make call left child, and it is going to return nothing. So from here we are just directly going to start the calls from right side only. For that I'll make a stack. This stack is going to be of this function. Okay, this function So just make this, and we are going to use another stack that is of going to be of this function. With this, we'll be able to clearly understand that what is actually happening. Okay, now let's start. From here, we move to, from 10, we make a call to, first 10 made a call to left child, where there we didn't get anything. So now we are going, this part is already executed for 10. Now we are going to make a call to right child. For here, it got to 30, sorry, 30, and right call has been made. And initially our fire node was what, 50, so we are going to pass fire node as it is, right? Now 50 here, 30 made a call to left child. It is not going to give us anything. Now it is going to make a call to right child with what, with with fire node as 50. As it makes call to its right child, we got to where, we got to 50, and with this we hit our base condition. One of the base condition, what was our one of the base condition? If root's value, if this current node's value is equal to fire node, then we have to do something. What we have to do, we have to call this burn tree function. So for this 50, the burn tree function is being called. So for this 50, the burn tree function was called. That is, here root was passed. What was going to be the blocker node? The blocker node initially is going to be nothing, so it is going to be null, because here we can see that we have passed null. And now time is that the time, total time, here we will maintain another variable, that is max time. Initially it was 0, and now the time, sorry, now here this LT means nothing but left time, RT means right time, so don't get confused with this notations. Now let's begin, let's continue with our dry run. Here we are here with 50 as our root node, and blocker node is nothing, and time is also 0, because here you can see that time has been passed as 0. Now from this 50 we make a call to left child, that is from here we drop to here. As we go to 60 time, let's write time here as 0. As we go to, or instead we write time as 0 here, we make a left call. Okay, this is going to be null, and we make a left call, and here we go to 60 with time 1. This means that the time taken by the fire to reach to 50 is going to be 1. Okay, now from here 60 makes left call, right call, blocker node is null only, blocker node is null only. 60 makes these both calls because it has null. It is going to return what, it is going to return us nothing. So with this, max time is going to be updated from 0 to 1, because currently time is 1. Therefore both the calls for 60 are done. It is going to wipe out of this stack. Now we are at 50 again. From 50 we drop to 70, that is with right call. 70 also has time 1, so it is not going to affect our max time, so we are going to wipe this out of the stack. So both the calls for right and left, for both the calls for 50 are done. It is going to return what, or from here it is going to update max time, and from here it is going to return 1, that is to where it is going to return 1 to 30's right child, that is for 30 it is going to return 1. Okay, so with this, work for 50 is also done from here, and from here it is going to return what, it is going to return 1. So now currently 50 is done, work for 50 is done. Currently this 30 is having value as 1. I'll erase this 50 because this is going to create confusion. So now currently the time, the right time for 30 is going to be 1. That means from 30 side, this one tells us that, this non-negative value tells us that from the right side of the 30 we found the node, or we found the particular node from where the fire has started. And this means that if fire has started from this part, and this one indicates that the whole tree below it, that is the whole tree at the right side, the whole tree at the right side has already burned down. Now it has to check, this is burned down, now it has to check for the left side. Okay, now let's go. For right side it is burned. Now when it gets a non-negative value, it is going to go in this function, that is, now we are here with 30 as our root node and what, 50 as our blocker node. Okay, here 50 is our blocker node and 50 was nothing but our starting node also. So now 50 is a blocker node. So here it comes with 30 comes with 50 as a blocker node. I'll write 50 here. Now the time it is carrying with it is nothing but 1. Now it makes call to left child, that is to 40 with time 2. Now maximum time is going to be updated with what, with 2. It is going to make call to left and right, and blocker node is still 50. With this it is going to have nothing, so it is going to return. So here max time is updated, and this is going to get out of this particular this particular function, and from here it is this 30, this thing is done for 30. Now it is going to return what, its previous time, that was 1 plus 1. That means this is going to return to 10 with value what, with value 2. This 2 is nothing but our time. Now with this we fall to where, it was at the right side of the 10. So at the right side of the 10 we got what value, we got 2 as an hour time. Our work for this 30 is already done. Now this 10 comes in this function, this 10 comes in this function with root node, with the blocker node as 30, and time, what is time here, the time is going to be 2. Now this is going to go here, 10 is going to call to this function, and everything is going to go according these steps. First it is going to call to its left child, that is going to be 20. Here time was what, time was 2. It made a call to left child, blocker node is nothing but 30. Here also blocker node is going to be 30, right? Now it made a call to 20 with time 3. Our time is going to update, it is going to be 3. Similarly it is going to make a call to its left child, it is going to 100 with time 4. Our time is going to be updated, max time is going to updated. Now from here it is going to make a call to left and right, blocker node is going to be same, there is nothing, so it is going to wipe out of the stack. With this it is going to make a call to right child, but there is no right child, therefore it is also going to be wiped out of the stack, right? This wiping out means that this much tree is already burned, this much of the tree is burned, right? And this is also burned. So from here, now what we can say, now at 10 what we are going to do, we are going to make a call to right child, but right child is what, right child is 30, and 30 we have sent here as blocker node, so it is not going to go at that side. So both the calls for left and right are done for the 10, so it is going to wipe out of the stack. So in the main function it is going to return answer, but what is it is going to return from here, so it is going to return r plus 1. But in the main function from where we made a call, that is, I'll show you. From main function here we made a call, where is that, yes, from here we made a call, but what we are printing, we are printing a total time taken, therefore we are going to print this 5. So total time taken to burn this tree that we have taken as an example is going to be 5. If you calculate, we are going to get the same answer. Let's try to calculate this. Let's say we are starting from this node, so to go here it takes 1 unit of time, to go 60 it is going to take 1 unit of time. To go 40, it is going to take 2 unit of time. To go 30, it is going to take 1 unit of time. Here it is going to take 2. From here it is going to take 3, and from here it is going to take 4. Oh, sorry, after 3 it is going to be 4, not 5. This is my silly mistake. It is going to be 4. By mistake I have written 5. So it is going to, because you can see that after 3 it is going to be increased by 1 only, no, not 2. Therefore it is going to be 4. I by mistakenly I wrote 5. So again we will calculate 50. Here it is going to take 1. Here it is going to take 1, because these two are going to burn simultaneously. From here it is going to take 1. From here it is going to take 2. To 10 it is going to take 2. To 20 it is going to take 3. For to 100 it is going to take 4. So it is going to be going to return 4 as an answer. So I hope this was clear to you. So thank you for this video. Let's meet in the next video.